So the first day, remember, we talked about statistical questions, which would help us to collect information. So that's kind of where we would begin with statistics. Yesterday, we talked about measures of center, where we can find the middle of the data. Those were mean, median, and mode. And then we talked about measures of variability, one of which is range, and another one we'll talk about later. So today what we're going to talk about is like how to graph it, specifically two different kinds of graphs. So there are three that we really cover in 6th grade, and today we're going to talk about two of them. So on your note sheet, that's a beautiful blue streak.
Oh my God, right? Nathaniel.
Yeah.
Shh. She's recording.
Okay.
Closing. The recording can hear you.
All right, so the two that we're going to talk about are a dot plot and a histogram. So a dot plot is a number line. It's also sometimes called a, oh gosh, I lost it. It sometimes uses X's instead of dots to represent the data, but it's still a number line with columns of data that are made up of dots or X's. A histogram is probably something that's new to you, and it has to do with ranges of numbers. Ranges of numbers. For instance, if I asked you all how many text messages you sent yesterday, I would probably get roughly 30 different answers. Probably most of you would not have the same numbers. And so it wouldn't really be useful. So histogram allows us to get ranges of information to make it make more sense and to be more useful. And that's what we're going to talk about today. There's a box and whisker we'll get to, but I do want to mention this word at the bottom. You might want to underline it, circle it, outlier. So this is a word we'll be talking about over and over again, but an outlier is a number that is far from the others. So, for instance, if we were to try to get some data about the ages of the people in this classroom, well, there would be one outlier that would really change the mean, right? Who was it? Me, right?
Yeah.
Not you. Me. Okay, because all of you are roughly the same age, and I am way far away from you. So an outlier can sometimes change the meaning of our data. So sometimes outliers need to be taken out before our information can be useful. And that's kind of what we'll be getting to in a little bit. All right. So let's go straight into histograms first. So it is very common for people to think that histograms have something to do with history. And I wrote you a big note that says, has nothing to do with history. I even put you a not sign. So remember, not about history. Histograms are not about history. They are about ranges of numbers. For instance, this little one that I have here on the board has to do with the results of an exam. So we have students, we have the number of points that they got on the exam, and you see there's not one bar for each number of points. Instead, it's how many people got between 0 and 10 points, how many people got between 30 and 40. So which number of points did approximately 20 people get? Which number of points did approximately 20 people get? Gianna? That's a little bit more than 20. There's one a little bit closer. That one's not wrong.
70 to 80.
Yeah, 70 to 80. It's pretty much right there on the 20 mark. Okay? Now, do we know if they made a 70, a 71, a 72, 73? We don't know that, right? Because it's a range of data. But we just know that somewhere between 70 and 80 were where their scores fell. Okay? That's the idea behind a histogram. It's a range. Okay. So let's make one of these of our own. So I'm assuming and believing that you probably all slept a different number of hours last night. So I want you to choose a category that your sleep from last night falls in, and we're going to make a tally where those belong. Now, as you are making a tally, as people are making tallies on the board, I want you to copy it on your paper. So we're going to do this together. So make sure your tally matches this one. This is roughly what we said as far as our amount of sleep. So now we're going to take that and we're going to make it into a graph. Now, each one of these, this is important because you're going to see this word again, and some of you are going to ask me, and I'm going to say, remember, I just told you that answer. So each one of these things right here, this is called an interval. It's called an interval. As a matter of fact, I would just write that word somewhere where you'll see it. Interval. All it means is a range of numbers. So how many people fell in which interval? So in the 9 or more hours, we have 3 people in that interval. That's all it means. Okay? So we have 7, 3, 7, 7, 3. Interesting numbers. Okay. Now let's make a graph. So you have this on there. So first of all, we need to start by figuring out what's our tallest bar going to be. 7, right? Okay, so, and it just so happens that we have 8 things going up, so that's going to be no problem for us. So let's first number the left-hand side so we know how many people. So when we go here, when it's at that line, that means 1 person, 2 people, 3 people, 4, 5, 6, 7. Okay? Now, so for our 0 to 2, we had how many people? 7. So let's make our bar go up to 7. Shh. Hey, stay with me. Just make the bar. Shh. Quiet, please. Okay, for our 3 to 4, we had, so make our bar at 3. Okay, for our 5 to 6, we had 7. Again. You are not alone. 7 to 8, we have 7 people. And then 9 or more, we have 3. Okay, now we have created a histogram of our information. Each one represents a range of numbers. Now let's use our histogram and we're going to answer a few questions. So you look at your graph that you've made and let's answer these questions. Number 1, how many students slept less than 5 hours? Raise your hand when you know. How many students, Aiden? 10, right? 7 plus 3. Very good. How many students were surveyed? In other words, what was our sample? How many people were surveyed?
27.
27, because 7 plus 7 plus 7, that's 21, plus 6 more, that's 27 people. Very good. How many students slept more than 4 hours? Gianna? 17, because it's 7, 7 plus 7 plus 3. Very good. Let's see. How many students got more than 6 hours of sleep? 10. 7 plus 3. Very good. How many more students got 7 to 8 hours of sleep than got 3 to 4? How many more? 4. Good. 7 here, 3 there. Subtract. Okay. Do you know exactly how many students got 5 hours of sleep, everybody? No. There's no way to know. So we don't know exact numbers from this. We know ranges of numbers. And those are called intervals. Very good. Very good. Okay. All right, so let's talk about dot plots for just a second. So remember, sometimes they have dots like this, sometimes they have X's, just depends. The big thing about them, notice at the bottom there, it is a number line. And that's part of the key to these. They are number lines. So let's look at creating one. All right, so this is a shoe size dot plot. So this is a fictitious group of people and their shoe sizes. Now, a couple of things as we create it. Remember, as a matter of fact, let me go back for a second. Notice that they're evenly spaced out and they're one on top of each other. So that's important because the height of your dots represents more people. So that's why that part of it is important. So let's make this together. So our first number is 8. So we're going to put one dot on 8. Try to make them as even as you can. Our next one goes on. Good, 6. Our next shoe size is 12. Then we have a 7. And then another 7. And then we have a and a and a and a and then a. Very good. All right, so it should look like that. Okay, so notice that they're kind of evenly spaced out and right on top of each other. That's key. Now, do we have an outlier in this situation?
Yes.
It's the answer 12. Excuse me, it's the answer 12. Very good. Okay, now let's answer a few questions about these. So, what is the most common shoe size? That's the same, remember, as mode. James, what's the most common? 7. Very good. Okay, because we had 3 7s. What is the least common shoe sizes in the data? So don't ignore the ones that don't have any answers. The least common ones in the data.
12, 9, and 5.
Good. 12, 9, and 5. What is the range of shoe sizes that we have here? What is the range, Kylie? Seven. Is that right? Yes. Because 12 minus 5. The biggest one is 12, smallest one is 5. Very good. All right, now, the median. We need to talk about this for a second because people get a little bit confused about the median. It's the one in the middle, right? So there are a couple of ways that you can find the median. One way, the easiest way, if you can see it, if it's not difficult for you, is to look at the numbers and say, what is the, how many numbers do we have? How many actual shoe sizes do we get?
1. Wait, no.
How many shoe sizes?
6, 10.
Yeah, I'm sorry, people. I should have said people. But yes, 10 is correct. So we have 10 people up here, right? 1, 2, 3, 4, blah, 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 10. All right, so we have 10 people up here. So if we were going to find the middle of that, because that's the median, it would fall between the 5th and the 6th one, right? The median would be between the 5th and the 6th one. So the easy way, if you see it, is to find the 5th and the 6th numbers. 1, 2, 3, 4, 5, and 6. 5 and 6 are both 7. So the median is 7. Add them up and divide by 2. Okay, if you don't see that, and that can be difficult for people to see, another way you could do it is to cross out the numbers from each end. 1, 1, 2, 2, 3, 3, 4, 4. And then what's left are those 2 in the middle, 7 and 7. One more way is to write out the data that goes with it. So our data is 5, 6, 6, 7, 7, 7, 8, 8, 9, 12. And then find what's in the middle. Okay? Those are 3 different ways to find the exact same information. So whatever's easiest for you is the way that you would do it. So what is the median of our data? 7. So what is the sample size, as in how many people were surveyed? What is the sample size? 10. And then we already talked about the outlier. Okay? Now I want to talk about one more thing that is not on here, but it's going to be on what you're going to do in just a second. So let me see if I can pull up a blank screen for a second. So there's one more thing, and we're going to get more into this later, but there are a couple of questions that you're about to do that have to do with this. So I want to mention it really quickly so you'll know it. So generally, data goes in what they call a bell curve, kind of centered in the middle, goes down on the sides. But sometimes it's what they call skewed. Write this word somewhere on your paper. S-K-E-W-E-D. Skewed. That means that the data doesn't come up in the middle and go down on the sides. And it can be skewed either left or right. And I had a hard time remembering this, and I will give Grayson credit. Last period, she told me a really good way to remember it, and I liked it. So let's say that we had a histogram, and we had some tall bars over here, tall bars, and then it goes smaller, smaller, smaller. Looks like that, okay? This is what we call skewed because it doesn't just go up in the middle. So it's skewed, and it's skewed to the right. And here's why. And this is what she said. I love this. She said, if you made a slide, slide, if you made a slide and it went down, you would end up to the right. Okay, now my brain says skewed. It should say to the left. That's what my brain says. So that's why I like her example. It's skewed to the right because it goes down to the right. Let's say that our numbers, and we'll get into more of this later. This is just a brief introduction so you can be ready for a couple of questions out there. So if our data looked like this, oops, that's not it. If it looked like this, what would we say it was now? Skewed to the left because it goes down on the left. So skewed to left. Okay? All right. Now, that's it for today on the lesson. Now let's go to what we're going to do.